In this video, we're going to talk about theoretical probability and then experimental probability. Let's dive in and just start talking about theoretical probability. First, start by talking about theoretical probability. When we're trying to describe probability, what we're going to want to do is use P and then, in parentheses, an event. P being the probability that an event is going to happen. And so say we're flipping a coin. Well, if we want to figure out the probability of of flipping heads, what we're going to do is we're going to have, in a fraction, we're going to have the number you want all over the number of possible outcomes. Number of possible outcomes. So it's pretty much the chances of something happening that you want to have happen over all the possibilities that could happen. Okay, so from here, let's take a look at another example, or an example, where we can start thinking about probability. In this first example, let's say we have a red number cube and a blue number cube that are rolled. So we have a blue number cube, in other words, a blue die, and then we also have ourselves a red die. So there's my red die. I hope you like my illustrations, they're super fancy. Okay, and then as these are rolled, if all numbers are likely and are equally likely, what is the probability that the sum will be 10? And what they're asking is well, if I know that if I roll a 1 and then if I roll a 2 over here, the sum equals 3. And so we're looking for all possibilities where we have when I add them up together, I get 10. One way that we could think of this is, well, we could roll a 5 here, and then in red, we could also roll a 5. So that's one possibility. The other possibility is we could roll a red that's 5 and a blue that's a 5. So that's all in one. Another way we could do it is, well, we could do a 6. And then in blue, well, to get up to 10, we're going to need 4. The other way that we could do it is we could have 6 blues, and then in red, we could have 4 there. Okay, so that means that we have a grand total of 3. This is one option, that's another, and there's our third option. But we also probably want to figure out what is the total possible outcomes. If I just do my red die, so here's my red die, and if all I roll is a 1, let's say I do this 6 times, that means that with the blue, if I roll that, I'm going to also roll a 1, or a 2, or a 3, or a 4, or a 5, or a 6. This is one set of permutations. If I was to roll in the red, let's see, if I was to roll a 2 every single time, the other set of permutations that I could have would be 1, 2, 3, 4, 5, 6, and so on. If we just look at this image, this is one way that we can tell what we're looking for. Notice how I have, oops, there you go. Notice how I have a whole series of 1s here, and then 1, 2, 3, 4, 5, 6. That means that I have a 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. A 6 by 6 box. That means I have a total of 36 options. So my possible outcomes here, there's 36. And the number that I want, well, there's 3 different ones that add up to give me the score of 10. So it's 3 over 36, which also equals 1 over 12, because I can reduce. The next thing we're going to talk about is the complement of an event. The complement of an event, E, or of that event, is the set of all possible outcomes in that sample space not in E. In other words, the complement equals 100% minus the event probability. Well, let's take a look at this and see how this would work. Say we're playing a game of Battleship. In this game of Battleship, there are 5 ships and a 100-hole grid. In other words, our grid is 10 by 10. And players try to guess the locations of the opponent's ships and then sink them. I hope every single one of you have played this game before. At the start of the game, what is the probability that the first shot misses all targets? So this is going to be a complement question. We're going to start off with 100%, and then we're going to subtract the event that we hit a ship. Okay, so total we have 100 squares, And so we know that our denominator, this is all the events possible, is going to be 100. And then the number of holes covered, well, if we add all of these up here, 2 plus 3 plus 3 plus 4 plus 5, that should give us 17. Okay, that's the likelihood that I'm going to hit something. And so what I'm going to do is I'm going to do 100% minus 17 over 100. And the likelihood that I miss something is going to end up being 83 over 100, or 83%. The last piece we're going to talk about is geometric probability. And geometric probability is a theoretical probability that uses ratios of lengths, areas, and volumes. Say I have 3 semicircles with diameter 2, 4, and 6 centimeters, and they're arranged in this figure that we see right here in the picture. If a point inside the figure is chosen at random, so inside the figure meaning if it lands inside this area right here, what is the probability that the point will land inside the shaded region? So this area right here. Well, what we need to do is we need to figure out the total area. So for starters, we need total area. And then the area that we want is the shaded area. Okay, so to figure out the shaded area, well, the total area first. Well, we know that we're going to have ourselves a large semicircle, and that the diameter, if the diameter is 6, the radius is going to be 3. All right, and then let's draw ourselves a circle here. So we got just a quick recap. Here's my diameter from one side to the other, and then here's my radius from here out. And if I want to figure out the area of a circle, I'm going to do pi times radius squared equals area. Okay, so in this case, since we're working on a half of a circle, I'm going to do pi times the radius, which is 3, squared, and then half of a circle divided by 2. Well, that gives me 9 pi over 2, so 9 pi over 2, and that gives me 4.5 pi. Okay, super. Well, let's have our part of our answer be over here in blue. 4.5 pi. That's the total area. Okay, now what we need to do is we need to start subtracting stuff, because I want to figure out, once I chomp away at this larger one and then also at this smaller semicircle, what's the shaded area. So I know I'm going to start off with 4.5 pi, and this is units squared, and then I'm going to subtract the other 2 areas. Okay, so let's figure out if my diameter, let's do this one in magenta, if my diameter is 4, then I know my radius is going to be 2, so I'll do pi times 2 squared divided by 2. Well, pi times 2 squared is 4 pi divided by 2 is 2 pi. So let's subtract 2 pi. And then let's also do this smaller area here. Let's do that one in brown. So instead of 4, my diameter is going to be 2, so my radius will be 1. All right, so then I'll do pi times 1 squared over 2, which ends up being 1/2 pi. Right, so here's pi over 2. Okay, so 2 pi plus pi over 2, that's 2.5 pi. So 4.5 pi minus 2.5 pi, that leaves me with 2 pi. Let's do this in green. What I'm left with is 2, oh, that's not green. Green, there we go. What I'm left with is 2 pi in the top, and in the denominator I have 4.5 pi. And the cool thing that happens here is that my pi's cancel out. So those go away, and I'm left with the ratio of 2 over 4.5. And if I was to plug that into the calculator, I'd probably get about 4